Okay, the goal of today's lesson is to solve systems of equations. We're going to do it by adding and subtracting equations. We're going to be using a method called the elimination method. So the goal at the end of today's class is to say, I can solve systems of equations using the elimination method. Let's talk about that elimination method. The elimination method is a way to solve systems by eliminating one of the variables through addition or subtraction and solving for the other variable, the variable that has not been eliminated. Once I have a value for one variable, it's very easy for me to find the value of the other variable, the one that I eliminated. And I simply do that by plugging in. And of course, we know the system has a solution, and that solution is very often written as an ordered pair. You write as an ordered pair. You know me, I like to get right into it. I want to practice. I want to show you how to do it. 3x minus 2y equals 18. 4x plus 2y equals negative 4. Hopefully somebody out there is screaming to themselves, hey, these two guys, negative 2y and positive 2y, are opposites of one another. Mr. Finazzo mentioned something about adding or subtracting. If we add those guys together, I'm going to get a 0, going to cancel out those y's, and you're exactly right. We can add these two equations together. The equal sign allows us to do that. So 3x plus 4x is going to give me 7x. Negative 2y plus positive 2y gives me 0. And this, of course, is equal to 18 minus 4 gives me 14. Well, can we solve for x? I hope so. Divide both sides by 7. And we know that x is equal to 2. Perfect. We've got one of our variables. We know that x is equal to 2, but we're looking for the solution to the system. So that means there has to be a corresponding y value. Well, all you need to do is take one of these equations. I'm going to pick the top equation and plug x in to that equation. Plug the value for x, or the 2 there. So let's try it. We have 3x minus 2y equals 18. We know that x is equal to 2. It tells us that right here. So let's replace the x with 2. 3 times 2 minus 2y equals 18. 3 times 2 we know is 6. Minus 2y equals 18. Subtract 6 from both sides, and I'll get negative 2y equals 12. Divide everything by negative 2. Okay, simple solutions. We get negative 6. I've got an x value of 2. I've got a y value of negative 6. There's my solution. 2, comma, negative 6. Now, the system has one solution. How do we define the system? Well, we know that it's consistent. Consistent just means it has at least one solution. And the fact that it only has one solution means that it's also independent. We eliminated our y value with the first step, right here. After we eliminated our y, we solved for x. That was simple. We did that in here. We took our x value, we plugged in, and we then solved for y. Once we got our y value, we came up with a solution of 2, comma, negative 6. When my x is 2, my y is negative 6 in both of these equations. Let's try another. Remember, you can add and subtract equations. 2y minus 3x equals 9. 3y plus 3x equals 11. What do you notice? I hope you notice this guy right here. Negative 3x and positive 3x, they're going to cancel if we add. 2y plus 3y gives me 5y is equal to 9 plus 11 gives me 20. This part's easy. Divide by 5, divide by 5, we get y equals 4. Now that y equals 4, we know that y equals 4. Let's plug in y's value to find out x. The first time I used the top equation, this time I'm going to use the bottom equation. 3y plus 3x equals 11. I'm going to replace my y with 4. That's what it tells me. So 3 times 4 plus 3x equals 11. 3 times 4 we know is 12 plus 3x equals 11. Subtract 12 from both sides. 3x equals -1. Be careful, make sure that your signs are correct. Solve for x easily, divide by 3. Somewhere out there someone's saying this is equal to -1/3. I hope we're not going to 0.333 or -0.333 repeating. I think that we've shown it doesn't work all the time, or it's not the best way to represent it. So what's the solution? -1/3 and 4. One solution. A solution, we know it's consistent. And because there's only one, we know that it's independent. Great stuff. Remember, we can manipulate the look of equations any way that we want. 2x plus 3y equals 20. 2x plus 7y equals -4. What's the problem here? Well, one of the problems is if we add these together, we're not going to eliminate anything. We could subtract, but then it gets a little bit ugly trying to remember what to do. So here's what I'm going to do to make our lives a little bit easier. I see 2x and 2x. I want to change one of them. I want to change one of them to a negative. Well, I can do that by multiplying by -1. And I'm going to choose the top one just because it's a little bit easier to work with. This -1 belongs to each term. -1 times 2x is -2x. -1 times 3y is -3y. Is equal to -1 times 20 is -20. I'm done with this top equation. I've rewritten it underneath. I've manipulated it by multiplying everything by -1 or changing all of the signs. Now, we should be able to say, wait a second, these guys right here, those guys right there are going to be eliminated if I add this thing together. We want that. So let's add them together. 2x minus 2x gives me nothing. 7y minus 3y gives me 4y is equal to -4 plus -20 gives me -24. Should be able to solve for y kind of easy. Divide by 4, divide by 4, and we know that y is equal to -6. Tells me this right there. So, let's go back to our two originals. We can take either one of these and we can plug in y equals -6. We manipulated the top, so let's maybe use the bottom. We've got 2x plus 7 times, well, y value is -6 now. We'll plug in -6 equals -4. Great. 2x positive 7 times -6 is -42 equals -4. How do I solve for x? Add 42 to both sides. 2x equals 38. Okay, divide by 2. X equals 19. Oh, we've got ourselves our ordered pair. 19, comma, -6. Again, how could I define this system? Consistent and independent. Great. Let's try another one. So here we go. 5x minus 7y equals 18. 15x minus 21y equals 54. We can see, let's multiply the top by negative 3. In doing so, negative 3 times 5x gives me negative 15x. Negative 3 times negative 7 gives me positive 21y is equal to negative 3 times 18 gives me negative 54. You'll notice that, hey, all of these terms are going to cancel out. 0 plus 0 equals 0. Infinitely many solutions. So we say that it's consistent because it has solutions, but it's dependent. Quick review. Elimination method. We add and subtract equations to eliminate a variable. Solve for the variable that we have left, and then plug that variable in to get the value of the other variable, the variable that we eliminated. And remember, you can manipulate equations any way you want, simply by multiplying or dividing the entire equation. Homework, worksheet 9.4 AB, and I will be at Extra Help tomorrow morning at 7 a.m. Hope you guys have a great rest of the day.